You check your phone. It works perfectly. The GPS pins your location to within 3 meters. Satellites overhead are humming along. The sky outside is the same blue it was yesterday. Nothing feels wrong. What you don't know is that right now, somewhere between 1,800 and 3,200 kilometers beneath your feet, liquid iron is spinning. It has been spinning for roughly 4 billion years. And that spin is the only reason you are alive. Now imagine it stop. Not the Earth itself, just the magnetic field it generates. Imagine that tomorrow morning you wake up and that invisible shield wrapped around your planet, the one you have never once thought about, is simply gone. The first thing to understand is what it actually does. Earth's magnetic field, which scientists call the magnetosphere, stretches outward from the planet in a teardrop shape, extending tens of thousands of kilometers into space on the side facing the sun, and trailing far longer on the night side like a comet's tail. You cannot see it. You cannot feel it. But without it, the sun would slowly strip your atmosphere away, particle by particle over millions of years. And on any given Tuesday afternoon, it is the only thing standing between you and a wall of charged particles moving at 400 to 800 kilometers per second. That wall is the solar wind. It is not wind in any sense you would recognize. It is a constant stream of electrons, protons, and helium nuclei blasted outward from the sun in every direction, every single second. When it hits Earth's magnetosphere, the field bends it around the planet. The particles are deflected, compressed, redirected, contained. The magnetosphere absorbs the punch. You feel nothing. Now remove the field. The solar wind hits your atmosphere directly. In the first hour after the field disappears, you probably still feel nothing. The atmosphere itself has mass. It acts as a partial buffer. Satellites in low orbit begin experiencing unusual drag. Some GPS signals flicker. Nothing catastrophic yet. You go about your morning. But here is what is already happening above you. Ionizing radiation, high-energy X-rays, and ultraviolet light from the sun is now reaching the upper atmosphere with nothing to deflect it. Normally, the magnetosphere compresses and channels these particles into the polar regions, which is why the auroras exist. The northern and southern lights are literally the magnetosphere leaking. They are what charged particles look like when they slip through. Without the field, those particles do not get funneled to the poles. They spread across the entire sky. People at the equator begin seeing auroras for the first time in their lives. It is genuinely beautiful, and it is the beginning of the end. Within 24 hours, people with pacemakers start noticing interference. Radio communications degrade. The charged particle bombardment begins disrupting the ionosphere, the layer of the upper atmosphere that makes long-distance radio transmission possible. Emergency services lose connectivity in certain regions. Airlines reroute away from polar paths, where radiation levels have spiked sharply. Within weeks, the ozone layer begins deteriorating. The ozone layer, a thin region of O3 molecules about 15 to 35 kilometers above your head, absorbs ultraviolet radiation from the sun. It is also sensitive to charged particle bombardment. Without the magnetosphere filtering those particles out, the ozone chemistry is disrupted. The effect is not instant. It is gradual, but it compounds. Lucie Menviel and a team of researchers at the Institut de Physique du Globe de Paris have modeled what happens to atmospheric chemistry during geomagnetic excursions, periods when Earth's magnetic field weakens significantly. Their work shows that even a partial reduction in field strength accelerates ozone destruction measurably. A complete disappearance would be far faster. As the ozone thins, UVB radiation reaching the surface increases. UVB is the kind that causes sunburn in 15 minutes on a clear summer day. Now picture that exposure becoming inescapable. Plants begin showing damage. Phytoplankton, the microscopic organisms at the base of the entire ocean food chain, responsible for roughly half the oxygen you breathe, are especially vulnerable to UVB. Their population collapses do not announce themselves. They happen silently, invisibly, kilometers offshore. But the consequences ripple upward through every ocean ecosystem within months. On land, the picture shifts too. UVB damages DNA. Every organism that has not evolved for this level of radiation, which is essentially every organism alive today, because your ancestors have lived under the protection of the magnetosphere for hundreds of millions of years, begins accumulating cellular damage. Cancer rates do not spike tomorrow. This is a slow grinding pressure, but it is relentless. Here is the counterintuitive part that even scientifically literate people tend to miss. The atmosphere itself would not vanish immediately. This is a common misconception. You may have heard that without the magnetosphere, the solar wind would blast away Earth's atmosphere. That is true, but only over millions to hundreds of millions of years. Mars lost its magnetic field roughly 4 billion years ago, and its atmosphere has been thinning ever since. Today Mars has an atmospheric pressure about 0.6% of Earth's. But that took billions of years. On a human timescale, even across centuries, your sky does not simply evaporate. What kills you is not the absence of air. What kills you is the quality of the radiation tearing through it. Bruce Jakosky at the University of Colorado Boulder has spent years studying the MAVEN spacecraft data, a NASA orbiter specifically sent to measure how fast Mars is losing its atmosphere to the solar wind. His team's 2015 findings, published in Science, showed that Mars loses roughly 100 grams of atmosphere per second, which sounds large until you realize Mars has been doing this for 4 billion years. On Earth, with its remaining atmosphere still relatively intact, you would not notice the air thinning in your lifetime. But you would notice everything else. By the end of the first year without the field, global communications infrastructure has been significantly disrupted. Unshielded satellites have begun failing from radiation damage. The power grid is increasingly vulnerable to geomagnetic storm equivalents, except now there is no magnetosphere to dampen those storms. Solar energetic particle events, which the magnetosphere normally contains, now deliver direct hits to the atmosphere. Think of the 1989 Quebec blackout, when a geomagnetic storm knocked out power for 6 million people for 9 hours. Now remove the buffer that limits how often and how hard those events hit. They begin arriving without warning and without filter. Agriculture is under pressure. UVB-sensitive crops, wheat, soybeans, certain rice varieties, see yield reductions. Farmers adapt, but slowly. Migration begins in earnest. Away from equatorial zones where UV exposure is most intense, toward higher altitudes where thicker atmosphere offers marginally more protection. Populations that have lived near the poles discover that the radiation is actually worse there, because that is where what remains of the ionized particle flow is concentrated. Civilization does not collapse in a week. This is important. This is not an asteroid impact or a volcanic winter. This is a slow unraveling. But slow unraveling is in some ways more dangerous because it is harder to name. It is harder to mobilize against. It is harder to explain to a child why the world is different now than it was when their parents were young. The second counterintuitive truth is this: Earth has done this before. Not fully, not completely, but the magnetic field is not constant. It wanders, it weakens, and it has flipped, North Pole becoming South Pole, at least hundreds of times in Earth's history. Geologist Coe and researcher Previtt, studying ancient lava flows in Oregon in the 1990s, found evidence that the poles can shift startlingly fast, potentially within a human lifetime, not just over thousands of years. During these reversals, the field weakens dramatically before rebuilding in the opposite orientation. These are called geomagnetic excursions. The Lost Champs event, roughly 41,000 years ago, saw the field drop to about 5% of its current strength for around 1,000 years. Homo sapiens survived the Lost Champs event. Modern humans were alive during it. Cave paintings from France's Chauvet Cave, dated to around 36,000 years ago, were made by people living in a world with a dramatically weakened magnetic field. The Neanderthals, who were already declining by that point for other reasons, did not make it through. But the causal link to the weakened field is still debated. What is not debated is that the field was weak. Life continued, but the species alive then were living in a UV environment they had evolved within over millions of years. They had some existing resilience. The agricultural civilizations, the satellite networks, the power grids, the ozone-depleted crops, those have no such resilience. And here is what makes this thought experiment worth sitting with. The magnetic field is weakening right now. Not dramatically, not catastrophically, but measurably. Over the last 2 centuries, the period during which we have been able to measure it precisely, Earth's magnetic field has weakened by roughly 9%. There is a region called the South Atlantic Anomaly, a weak spot in the field centered roughly over Brazil and the South Atlantic Ocean, where the field is unusually low. Satellites passing through it regularly experience technical anomalies. It has been growing. Scientists disagree about what this means. Some see it as the early signature of a coming field reversal, an event that, based on the geological record, is statistically overdue, since the last full reversal was about 780,000 years ago and reversals typically happen every 200,000 to 300,000 years. Others argue it is simply normal variation and may stabilize or strengthen again without a reversal occurring. No one can tell you with certainty which is true, so you check your phone this morning. GPS works perfectly. Satellites overhead are humming. The sky is blue. Everything feels stable. And somewhere deep below you, 5,000 degrees Celsius of liquid iron is churning, sustaining the invisible architecture that makes all of this possible. And it has been doing so without interruption, without acknowledgement, without any help from you, for longer than complex life has existed on this planet. The magnetosphere is not something your body can sense. It has no smell, no texture, no color. But right now, in this exact moment, it is absorbing a storm of charged particles flying toward you at 500,000 kilometers per hour. And it is doing this so quietly, so completely, so invisibly, that you have never once had to think about it. Until now.